What if a simple DNA test revealed that you're genetically closer to a Stone Age farmer than to your own neighbors? That's the reality for people living on one Mediterranean island. While colonial powers swept across Europe, mixing and erasing indigenous bloodlines through thousands of years of conquest and forced migration, one group of people found the perfect hiding place, dug in deep, and refused to be conquered. They've been living the same lives, in the same valleys, carrying the same DNA for 8,000 years. These aren't museum exhibits or ancient bones in a lab. They're shepherds, fishermen, and farmers living normal lives, completely unaware that they're the most genetically precious people on Earth. Their blood carries secrets that died out everywhere else thousands of years ago. Welcome to Sardinia, where the impossible became reality, and the past never actually ended. Picture the Mediterranean 8,000 years ago. Small boats carrying precious cargo pushed west from the Near East. Seeds of emmer wheat and barley, herds of cattle and sheep, and the revolutionary knowledge of agriculture itself. These early European farmers represented humanity's greatest transformation, turning entire continents from hunting grounds into fertile farmland. The discovery that would change everything began with a corpse melting out of an alpine glacier. In 1991, hikers stumbled upon Ötzi the Iceman, perfectly preserved for 5,300 years in the ice between Austria and Italy. When scientists finally extracted DNA from his ancient bones in 2012, they expected to find genetic similarities with modern alpine populations. Instead, they discovered something that defied all expectations. Ötzi's genome clustered most closely with people living 400 miles away on a Mediterranean island. This impossible connection launched a genetic revolution that would rewrite the story of European ancestry. In 2016, a groundbreaking study published in Nature analyzed genome-wide data from 230 ancient Europeans spanning 8,000 years. Modern Sardinians showed the highest genetic affinity to these Neolithic pioneers of any living European population. Ötzi the Iceman, that perfectly preserved man frozen in the Alps for 5,000 years, clusters genetically closer to modern Sardinians than to his Austrian neighbors. Around 5500 BCE, maritime pioneers carrying distinctive cardial pottery finally reached Sardinia's shores. Radiocarbon dating from sites like Filiestru Cave reveals rapid colonization. Within just a few centuries, farming communities had established themselves from Sardinia's southern coasts to its northern highlands. Archaeological evidence from Su Caropu di Siri shows these colonists brought complete agricultural packages, domesticated wheat, barley, sheep, goats, and cattle alongside sophisticated pottery traditions. What made Sardinia special wasn't just who arrived, but who never came after them. The Mediterranean Sea formed nature's perfect moat around Sardinia's genetic heritage. Even during glacial maxima, when sea levels dropped 120 meters, underwater surveys confirmed that Sardinia remained separated from the Italian mainland by at least 200 kilometers of open water. Mountain chains running north to south created additional isolation within the island itself. Regions like Ogliastra, surrounded by peaks reaching over 1,800 meters, became genetic sanctuaries where populations remained isolated for millennia. This extraordinary geographic fortress would soon prove its worth when the greatest genetic transformation in European history swept across the continent and somehow missed one small island. This is exactly the kind of discovery that drives everything we do here at Ancestry Code, using cutting-edge science to reveal the hidden connections that reshape our understanding of human history. If you're fascinated by how modern technology keeps rewriting our origin stories, subscribe to our channel and join us on more journeys through time. Now, on to the video. Around 5,000 years ago, a genetic revolution began reshaping Europe. The Yamnaya culture of the Pontic-Caspian steppe had mastered horses, wheeled vehicles, and bronze metallurgy. Archaeological evidence from Sintashta and Archaim shows these steppe pastoralists developing the world's first war chariots and sophisticated bronze weapons. Starting around 3000 BCE, massive migrations carried Yamnaya DNA westward across Europe. In Britain, steppe ancestry increased from 0 to 90% within just a few centuries. Bell beaker cultures across Central Europe show similar dramatic genetic shifts. Ancient DNA from sites in Germany, France, and Spain reveals complete population replacements as steppe peoples mixed with or displaced existing farming communities. Sardinia alone remained untouched by this continental transformation. Archaeological evidence for steppe influence remains remarkably sparse. Minimal cord-marked pottery, few battle axes, and limited horse remains from this crucial period compared to mainland Europe. The 2020 study by Chiang and colleagues analyzing 3,514 Sardinian genomes confirmed what the archaeological record suggested: minimal steppe ancestry, less than 5% compared to 40 to 60% in most European populations. Sardinia had achieved the impossible, remaining genetically Neolithic in a Bronze Age world. From 1800 to 238 BCE, Sardinians developed the remarkable Nuragic civilization. Across their island, they constructed over 7,000 nuraghi, massive stone towers reaching heights of 20 meters. The UNESCO World Heritage Site of Su Nuraxi di Barumini showcases the architectural sophistication of these structures, with multi-story towers surrounded by defensive walls and village complexes. Excavations at sites like Santu Antine reveal bronze workshops producing intricate figurines and weapons using advanced lost wax casting techniques. Nuragic ships transported Sardinian obsidian from Monte Arci quarries across Mediterranean trade networks reaching Cyprus, southern France, and North Africa. Yet genetic analysis of Bronze Age remains from Nuragic burial sites shows remarkable continuity with earlier Neolithic populations. Despite extensive trade contacts, the core Sardinian population maintained their ancient character throughout this 1500-year period. But this splendid isolation was about to face its first real test. In the 8th century BCE, Phoenician traders established their first permanent settlements on Sardinia's southern coasts. Montesirai, founded around 750 BCE, became one of their most important Western Mediterranean outposts. Excavations led by Piero Bartoloni revealed a sophisticated urban center with residential quarters, industrial areas, and an extensive necropolis containing over 3,000 burials. Tharos, on the western coast, emerged as another major Phoenician port controlling trade routes to southern Spain and North Africa. Archaeological evidence shows these settlements imported goods from across the Phoenician world: ivory from Africa, silver from Spain, fine pottery from the Levant. But ancient DNA analysis tells a surprising story. Mitochondrial genome sequences from Phoenician burial sites, published in 2018, revealed limited genetic mixing with local populations. Phoenicians maintained distinct genetic signatures, linking them to Levantine populations while showing minimal integration with indigenous Sardinians. Even after Carthaginian control expanded across the island from 540 BCE, genetic impact remained concentrated in coastal trading centers. Roman conquest in 237 BCE brought dramatic political changes to Sardinia. Within a decade, the island became Rome's second overseas province after Sicily. Archaeological evidence from Cagliari and Porto Torres shows massive Roman urban development. Forums, theaters, aqueducts, and road networks connecting previously isolated regions. The Via Carrales linked the southern capital to northern ports, while countless villas produced grain for Roman markets. But recent paleogenomic studies reveal the limits of Roman genetic influence. DNA analysis from Roman period burials shows significant admixture only in major urban centers and lowland agricultural areas. The mountains remained unconquered, not just politically, but genetically. Communities in Ogliastra and the Ghenergentu Massif maintained genetic continuity with earlier populations. Medieval genetic analysis reveals the first substantial change since Neolithic colonization. Y chromosome studies published in 2013 by Francalacci and colleagues detected new lineages entering Sardinia during the medieval period. These genetic signatures link to Italian and Spanish populations, coinciding with Pisan, Genoese, and later Aragonese political control. Northern regions like Gallura show clear evidence of Corsican and northern Italian settlement, while southwestern areas display Spanish genetic influences. However, central mountain regions retained their ancient genetic character even through these medieval changes. Modern genetic studies reveal Sardinia's extraordinary preservation of Neolithic ancestry, alongside a fascinating parallel story from another corner of Europe. Remarkably, the Basque people of northern Spain and southern France share a similar genetic heritage with Sardinians, despite being separated by hundreds of miles of Mediterranean Sea. Both populations maintain unusually high levels of early European farmer ancestry, suggesting they represent different branches of the same prehistoric European family tree. While Sardinians preserved their ancient heritage through island isolation, the Basques survived in their mountainous homeland by developing one of Europe's most distinctive cultures and languages. This genetic connection across geography reveals how pockets of ancient European heritage survived the great migrations that transformed the rest of the continent. The 2018 study by Chiang analyzing whole genome sequences from over 3,000 Sardinians confirmed their unique position among world populations. Sardinians maintain the highest levels of early European farmer ancestry of any living group, approximately 80 to 85%, compared to 40 to 60% in most European populations. These numbers represent more than statistics. They're proof that human heritage can survive against impossible odds. This genetic isolation created both remarkable benefits and significant challenges that tell a deeper story about human survival. Sardinia ranks among the world's 5 blue zones. With exceptional longevity, the island has the highest concentration of male centenarians on Earth. In villages like Perdas de Fogu and Vila Grande Strisaili, seeing men reach 100 years old is almost routine. Scientists believe this extraordinary longevity stems partly from genetic variants that accumulated in isolated populations over millennia. Specific genes linked to cardiovascular protection and cellular repair appear at unusually high frequencies in mountain communities. But isolation is a double-edged sword. The same genetic bottlenecks that preserved ancient heritage also concentrated harmful variants. Sardinia has the world's highest incidence of beta thalassemia, affecting 1 in 8 individuals in some regions. Type 1 diabetes and multiple sclerosis occur at rates 3 to 4 times the European average. These health patterns make Sardinian populations invaluable for medical genetics research into the fundamental mechanisms of human health and disease. The Sardinia project, analyzing genetic data from over 6,000 individuals across 4 generations, has identified dozens of disease-associated variants and provided insights into human genetic architecture. Population isolates like Sardinia serve as natural laboratories where scientists can trace how genetic variants spread through families and communities over centuries. Recent breakthroughs include identifying genetic factors behind autoimmune diseases and discovering new pathways involved in aging and longevity. These discoveries have implications far beyond Sardinia, potentially leading to new treatments for conditions affecting millions worldwide. What started as curiosity about an isolated population has become a medical treasure trove for all humanity. Each Sardinian genome tells a story that reaches back 8,000 years while pointing toward medical advances that could benefit future generations. In our modern world of constant migration and genetic mixing, Sardinians represent something unprecedented, a direct genetic link to Europe's agricultural revolution. They carry unbroken bloodlines connecting them to the brave pioneers who first brought farming to European shores 8,000 years ago. Geographic isolation created an accidental genetic sanctuary, protecting irreplaceable heritage through millennia of European transformation. But Sardinia's story isn't just about preservation, it's about active resistance and cultural continuity. Traditional Sardinian shepherding practices passed down through countless generations mirror archaeological evidence from Neolithic sites. Ancient stone villages in regions like Barbagia maintain architectural styles that echo Nuragic construction techniques from 3,000 years ago. Even the Sardinian language preserves linguistic elements that disappeared elsewhere in the Romance-speaking world. This cultural persistence parallels the genetic preservation, suggesting that isolation protected not just DNA but entire ways of life. Phoenician traders, Roman legions, and medieval settlers all left cultural marks, but the ancient genetic core survived intact. Today, advanced genomic technologies continue unlocking secrets hidden in Sardinian DNA that reshape our understanding of European prehistory and human health. These mountain shepherds and coastal villages carry irreplaceable genetic information, linking us directly to our agricultural ancestors. Proof that sometimes the most important discoveries come from the places that time forgot. This was Ancestry Code, and as always, thanks for watching.